So we are on chapter number 4, which is random numbers. All good games require some level of randomness. So how do we generate random numbers in Solidity? The real answer here is you can't. Well, at least you can't do it safely. Let's look at why. Random number generation, why a key check to 56. The best source of randomness we have in Solidity is key check hash function. We could do something like the following to generate a random number. What this would do is take a time step now and message dot sender and incrementing announce a number that is only ever used once, so we don't run the same hash function with the same input parameter twice. It would then pack the inputs and use keycheck to convert them to a random hash. Next, it would convert that hash to a uint and then use modulus 100 to take only the last two digits. This will give us a totally random number between 0 to 99. So that's how we can generate a random number in Solidity. This method is vulnerable to attack by dishonest node. Uh, I have read this. It's something. It's have some old concept that were before the Ethereum merge. So I am skipping it. You can read it if you like, and also kindly read the proof of stake concept that is now in working. Proof of work is no more used uh, in Ethereum transactions. So do read about the proof of stake. There's a new method of uh, consensus mechanism of processing transaction. So I'm skipping it. So how do we generate random numbers safely in Ethereum? We can use oracles. We will going to see this in the future lessons. So let's skip it also. Now let's put it to a test. Let's implement a random number function we can use to determine the outcome of our battles, even if it isn't totally secure from attack. Give our contract a uint called random nonce and set it equal to 0. So let's create it. Uint random nonce equal to 0. Create a function called random mode. It will be internal function that takes a uint underscore modulus and returns uint. Okay, the function should increment random nonce plus plus. Finally, it should in one line of code calculate the uint typecast of keycheck6 hash ABI input pack now as a center random number and returns the value uh, modulus. Okay, that's what mouthful. If you don't follow that, just uh, take a look at the example above here. We generate a random number. The logic is very similar. Okay, let's take it from here. Yeah, and modulus. There it is, and just return it. I think that's the correct syntax. Let's check the answer. Yes, it's correct. So we have completed the chapter number 4. Now let's move on to chapter number 5.